Today's episode of Science Solutions Santa Cruz is like one of those crime shows like CSI or something where the characters are using forensics to help solve a murder. But instead, we're talking about condors, California condors. Myra Finkelstein joins me on the pod today. She's an adjunct professor of microbiology and environmental toxicology at UC Santa Cruz. And she's been studying these condors for decades. So we get into this issue of lead poisoning, where it comes from, some of the solutions that have already been implemented, some of the problems with that solution, some of the problems that we still face today, and some of the solutions that are still on the table to protect this iconic species. I'm Jonathan Hicken. Enjoy. In the studio today, I have Myra Finkelstein, adjunct professor of microbiology and environmental toxicology right here at UC Santa Cruz. Welcome, Myra.
Thank you for having me here today, Jonathan.
It's my absolute pleasure. It's so nice to meet you. And I was doing some research on your background, and you have an incredible story that led you to condors. We're going to be talking about condors mostly.
Yeah, one of my favorites.
But you have to fill us in on, take us as far back as you want to go in terms of how you were inspired to start to pursue this work.
So I've always been sort of somebody that loved animals. You know, growing up, I loved animals. I wanted to be a vet. I wanted to do anything I could to save animals. And so when I was in 7th grade, our science teacher had gone and caught a gardener snake in the hills by the school. And every single day in class, he was letting all the students handle the snake. And my friend and I, Susie Carlson, decided that the snake was unhappy and needed to go back home. So we liberated the snake to take it and go return it to the wild where it belonged. But unfortunately, someone saw us and we got told on, and we got called into the vice principal's office with my parents, and I was almost expelled.
Oh my gosh.
Yes, but
are we naming names on who ratted you out on this one, Myra?
I was thinking about it, but I don't know if I should. It depends on how far this goes back. But I mean, the good part of this was that the vice principal wasn't very happy that the science teacher was torturing the snake, and I'm not sure he was supposed to have caught the wild snake and brought it into the class. So that was a good thing. And then my parents laughed about it and thought that I'd have more time to play with my horse if I got expelled. So,
and did you? Did you?
Well, I did not get expelled.
Okay,
I think the vice principal was sympathetic to our cause.
Well, I can tell that your activist roots go back a long, long way. But that's not where it ended.
No, I just continued wanting to do something to save animals. I went to UC Davis studying as a pre-vet, but learned that, you know, I wouldn't be able to handle watching the animals suffer, so I wouldn't be very good for being a vet. I mean, I love my vet and I appreciate the vets. I'm so glad they do what they do, but I wouldn't be able to do that. So I went into environmental conservation work.
And what did that look like?
So some friends and I went and saw Paul Watson give a talk in Berkeley about his group, the Sea Shepherd Conservation Society, and how they were going out there and saving marine animals and getting in the line of fire to basically prevent illegal fishing that was killing so many animals, especially these huge drift nets, which were just basically big carpets of death. And my friend and I looked at each other and we were like, we want to go do that.
So to be clear, you were getting on vessels and getting, like, physically getting in the way of some of these illegal fishing operations?
Yes, if we could. I mean, our ship wasn't super fast, but we tried. But yeah, we did. We did end up interfering with some operations and trying to basically, our goal was to draw attention to these illegal drift netting vessels that were up there just causing massive destruction. My first campaign was in the Bering Sea with the Sea Shepherd Conservation Society.
Did it ever get hairy?
Yes, it did.
Yeah?
Yeah.
Do tell.
I mean, so the Bering Sea can be pretty rough. We were sheltering behind one of the Aleutian Islands at anchor, and the wind was shifting, and we couldn't start our engines. The chief engineer was locked in his cabin. He didn't want to come out, but we couldn't get the engine started. And I just remember, like, everyone seeming super panicked. And I think our job was we made chocolate chip cookies to try and lure him out to basically try to fix the engines so that we could move the ship. And because if the wind shifted, we would just basically have gone on the rocks to the Aleutians. And I spent many years with Sea Shepherd, and in talking to Paul, years later, I think he said that was one of the hairiest situations we were in.
Holy moly.
We didn't know. I didn't know. Like, I didn't know.
At that time, you were just on an adventure.
Trying to bake chocolate chip cookies and get the chief engineer to come out to get those engines to start again. But then when we got back, as soon as we hit some kind of port, he took off.
He was like, I'm done with this.
He didn't, yeah.
So your adventures did not stop in the sea.
No.
You then started to work on some wolf conservation, right?
Yes, one of the other campaigns Paul was involved with was he started this group Friends of the Wolf, where basically the Canadian government was illegally killing wolves. They were shooting them from helicopters on baited lakes in the middle of winter as this kind of wolf control program, but it was really in the northeast British Columbia by the Yukon Territory. And there was no sort of biological reason for doing this, except for people were sort of flying in non-native game for trophy hunting, and they didn't want the wolves up there interfering with it. And so my friends and I thought that we could be involved with that. We thought this was a great way to try to help, save the wolves. But Paul had gone in a couple of years before on skis to try to get in and sort of just witness the hunt and disrupt the hunt, and didn't get very far on skis. So his great idea was the new team would skydive in the middle of winter in northeast British Columbia. And my friends and I are like, we'll do that.
Sign me up.
So he said, okay, great. You're now co-directors of Friends of the Wolf. And we're like, okay. So then we started to learn how to skydive in, Davis, California, where we went to school. There was a skydiving place nearby. And we laugh about it now because we thought Paul was going to jump with us like the whole time until like the very end. And then we realized, wait, he's not learning how to skydive.
Literally throwing us out of planes.
Literally, he did not come and jump out of the plane, but we did. And we were able to basically, they paused the kill while we were there. They didn't want, to be shooting wolves with us, around. We jumped out of a plane in northeastern British Columbia to sort of occupy the area where we were afraid they were going to be shooting the wolves. We actually saw a baited carcass on a lake. That's what they used to do. So we jumped near there to sort of be witness. And they postponed the kill, but I guess this is the long way to go to how the story is that at the same time we had a generous donor offer to pay for a lawsuit. And so we were skeptical that the lawsuit would be effective. But we thought, well, we'll try all the tools in our toolbox. So the lawsuit was put forth by Paul George of the Western Canadian Wilderness Committee. And because this wolf kill was not quite legal in the sense.
Yeah.
And the one thing that was amazing was, so we jumped in and we postponed the kill. In the meanwhile, the lawsuit was going forward in the Supreme Court of British Columbia in Vancouver, and then the judge put a hold on the kill until the court case was heard. So they picked us up with a helicopter, and we went back to kind of check out how the lawsuit was going. And the one thing that really struck me at the time was Paul George was a scientist, and he had a lot of scientific credibility. Then the lawsuit, Paul George and his group, the Western Canadian Wilderness Committee, had standing, and it was the first time an environmental group achieved standing to basically to sue the government over this wolf kill. And I didn't realize this, but this had it was huge. It was like a precedent-setting case, and it was kind of a really big deal. We won the lawsuit, which was amazing.
Congratulations, yeah,
because they were illegally, they were basically having non-government people like going up there in the helicopters, and I'm tapping the table, going up there in the helicopters and shooting wolves without permits. So it was, or not the proper permits, I should say. So it was really amazing. We were super excited, and I realized, like, wow, I mean, this was having that credibility to achieve standing was such a big deal. And even Native communities later were able to use our lawsuit as standing, because it sort of basically said you didn't have to have an economic interest in the outcome to be able to sue for the cause.
Well, first of all, I mean, between being on the high seas and jumping out of planes, I mean, I can confidently say that is absolutely badass, Myra. That is incredible. It's such an adventure story. And what jumps out to me is this comment about the scientific credibility.
Yeah, and I was actually, because I took a leave of absence for my undergraduate to do the wolf kill, like to disrupt the wolf kill, to do the wolf campaign. And I thought, I'm going to go back and finish my degree. And at the time, it's hard when you're out there and you're you really feel like you're making a difference. You're on the ship, or I'm out there and we saw wolves from the plane, and I thought, we're saving them, And after the lawsuit was so successful, I thought, well, I at least need to earn my bachelor's degree. So I went back to school and finished.
And so now, today we're going to talk about the California Condors, but it's already clear to me that you went from passionate, sort of boots on the ground activism work to science. And I know that you're now I'm aware that you're involved in some real impactful policy solutions. And so this path of your work, to me, is just such a beautiful fit for the show Science Solutions Santa Cruz. So walk us through how, from the moment you decided to go back to your degree to how did you get to this moment today where you're working with the Condors?
Yeah, so after I got my undergraduate degree, I went back out on the ship and spent many years on the ship doing different environmental campaigns, trying to save marine species. And my mom actually kept saying, are you ever going to do anything else with your life? You're just going to stay on that darn boat. And one time at sea, we were in the Atlantic and we were heading south, and we crossed. It was a beautiful day at sea. So I'll just kind of set the stage, because it was one of those days that I loved. I mean, it was us on the boat, me and all these, these other 20 people that were out there to try to save the marine life that we were in. And we hadn't seen another ship or land for days. And so it was just us and the animals out there.
And the ocean.
And the ocean, I worked in the engine room, and I came up from my 4 to 8 watch and looked out over the ocean, and it was just like glass. And sometimes that Atlantic could be like a bathtub, and it was just like glass. And I thought, oh, this is so amazing. What an amazing feeling. And then all of a sudden, our ship passed over this convergence zone of trash, like this huge band of trash that stretched from horizon to horizon. And we freaked out. We're on the deck and we're like, oh my God. And we yelled at Paul, we're like, change the course. So instead of crossing over, we start tracking with the trash, and we're frantically trying to clean it up. Which is so, I think now, we wouldn't be able to, but we tried. We grabbed bits of net. I remember styrofoam coolers. I remember bottles, just all kinds of trash bobbing around. And we were just it was so terrible, because again, the ocean was like a bathtub, and from horizon to horizon, you could see this trash. And now I know that was the convergence zone that we came across. So soon Paul's like, well, we can't keep going. This is the wrong direction. We have to track back to where we were going. And I thought, what are we doing to the ocean? I know nothing about this. I know nothing about the pollution that we're putting in, the plastic we can see, or all the compounds we can't see. And at that moment, I decided to go back and study environmental toxicology.
What is environmental toxicology?
So it's understanding how contaminants affect wild species, like the environment. And I have done a little bit of human health stuff, because we're all related. But yeah, it's just understanding the effect, because I felt like I needed to understand how these contaminants, or this pollution that we're putting to the environment, was affecting them, so we could figure out how to fix it.
When you say environmental toxicology, I'm imagining almost like a detective TV show, forensics, and you're in a lab and you're studying all these. How does it actually work? How do you actually do the science of environmental toxicology?
It's kind of like that. I mean, a little bit. I love it. And I was really happy to find I loved it, because when I came back to school, I had been out for quite a long time. And I started volunteering in labs and just taking classes. And I learned that I loved it. I wanted to discover what was inside of those, bird feathers, or how do we evaluate if something's been exposed to something. And that's what you do. You take samples and you measure those samples for different kinds of contaminants that you're worried about. And then some of my work, which I'm sure we're going to talk about, which is lead isotopic analysis, is even more of that, where you can almost sort of trace sources and inform sources with that work. And it is so cool. It's like a forensic. And then once you have that information, you can make basically informed recommendations for fixing it. And that's where it was. I felt like I can make a difference here.
Well, let's just get right into the Condors then, right? So first let's start with just maybe a discussion about Condors themselves in this region, and maybe a little bit about their history, just to catch the listeners up on where we are today.
Yeah, so California condors are still an endangered species. They're listed as critically endangered, one of the rarest birds on Earth. They almost went extinct in the 1980s. There was only a couple of dozen left in the world. And so in 1987, the controversial decision, I say it was controversial because they decided to bring them all into captivity. And the problem was they weren't staying alive in the wild, and they were really worried about losing that genetic diversity of the ones that kept dying in the wild. They weren't breeding in the wild either. So they brought them all in captivity. And the one thing, which is why we have condors today, is that they breed really well in captivity and they do really well. So that's been incredibly successful.
And is that just luck that they breed well, or is there something about their evolution that sets them up for that?
Well, I don't think it's luck. I think it's their generalist hardy birds. I mean, they're not super stressed. They can eat lots of different things. They're scavengers. You can feed them mice or rats or pigs, or I once saw a bucket of fish, one of the forms showing what the birds have been fed. So
and they'll eat washed up whales and do all sorts of things, right? Yeah,
so they're kind of generalists that way. And then because they're big and they have you could think of them sort of like if you compare with a hummingbird, that can have a very high metabolic rate and it can be really stressing, it can be very difficult for handling. Condors are not that way.
And so that sets them up to
do better in captivity,
do better
with this sort of more stressful situations and things like that.
And so some forward-thinking folks decided to capture all of the condors, which there were only a few dozen at that time, bring them in and start a breeding program.
Yeah, and they actually had started the breeding program a little bit before, but they were worried that because they weren't breeding in the wild, they were dying. So they were really worried that people that made these decisions at the time felt that they were just if they didn't bring them in, they were gonna die out there. So they brought them in to basically create the captive breeding stock. And then they started re-releasing them into the wild in the early 1990s.
In this region or elsewhere?
They started in Southern California, which is where the last of them were caught.
Okay.
So,
and so when I'm familiar with the Pinnacles National Park population. In fact, I got to go there about a year ago and climbed up to one of these peaks. And
the High Peaks Trail.
Yeah. And is like I'll never forget.
They're so cool.
They're gliding above you and they're pretty close to you up there. And I could hear the wind sort of making their wings sort of make this kind of sound.
Yeah.
And I was just transfixed by these massive beings flying so close. In any case, it's the Pinnacles National Park population is the one I'm familiar with. When did reintroduction into that area begin?
First, they were introduced in Southern California. Then Pinnacles and Ventana Wildlife Society also started a reintroduction program, within another decade in the Central California. So we have currently sort of two sort of distinct flocks. We have the Southern California flock and the Central California flock. And the Central California flock is the Pinnacles National Park release site and the Ventana Wildlife Society release site. And then the Southern California flock is Fish and Wildlife Service release site.
And how are we doing today? How's the population?
So they do breed really well in captivity.
Yeah.
And so we breed them in captivity and then we release them into the wild when they're, basically between 1 and 2 years old. And then their mortality rate in the wild is too high. We just published this new paper a few months ago looking at the lead risk of condors in California. And unfortunately, they continue to have more die than are born.
I see. So, all right, let's rewind because I know that you played a role in identifying this lead poisoning dynamic.
So we should probably back up a little bit.
Yeah.
So condors also, I should just say, condors are the largest terrestrial bird in North America with a wingspan of 9 to 10 feet.
I mean,
so they're crazy big.
It's like twice the distance between me and you.
Yeah. So amazing. So I started working on condors when I was finishing up a postdoc here at UC Santa Cruz. One of the chapters of my dissertation was looking at lead poisoning in Laysan albatross on Midway Atoll. And because of that, I learned a lot about lead poisoning and understanding how to do these lead isotopic analysis for sources of lead poisoning. And my co-advisor, Don Smith, who's still a current collaborator of mine, came to me and said, would you like to work on condors and lead poisoning? I really think this could make a difference. I think you'd be really, I think you would really like working on it because I can see it making a difference. He knew I was really.
You wanted that, yeah.
So I said, sure, and I started working on it. And at first we were just looking at, these condors are highly managed. Almost every day biologists go out and try to find them. So we have near daily data on them. Where are they? Are they near the release site? Are they flying on the coast? Are they hunkered down in a tree somewhere? They capture them about twice a year, and they do health checks, and they all have transmitters, and some of them, or a lot of them now have also GPS tags, but they have radio transmitters, and they take blood samples. So we had all this blood sample data. So the first thing we did is we looked at all the blood samples, and we also looked at the lead in the birds that were basically lead poisoned, and we looked at ammunition samples from ammunition that was bought in California. And we determined a couple of things for this work. One was that these birds were poisoned all the time. I mean, it was insane how many times the birds are poisoned. About 20% of the population basically needs medical intervention every year. I mean, it's absolutely mind-boggling. Yeah.
So did you already know at that time that lead poisoning was a problem, or did you discover that?
Yeah, so they've known or suspected lead poisoning is a problem before that. And Don and one of his former graduate students, Molly Church, had published some work a few years before showing that lead-based ammunition seemed to be a source of lead poisoning to the birds. But it didn't have a lot of it had a little bit of traction, but not enough. And Don felt like that work needed to be expanded. So when I came on, we expanded that work. We did a couple of things. One, we showed that through looking at feathers, which is really amazing because a condor feather can grow over 2 months. These are very long wingspans, long feathers. Yeah.
I mean, that's like this big.
Yeah. Yep. And so you can look at little sequential feather sections and recreate a whole lead exposure history over the time frame of feather growth.
Oh, wow. So what that means is you can kind of like look back in time when that feather started to grow and when the lead started to appear in the growth of that particular feather.
Yeah, and you can see these peaks of exposure, throughout the feather growth where these birds are repeatedly exposed to lead because when the lead is in the blood and that feather is basically perfused with blood, that feather material, the feather will pick up the lead. And so you can see the lead and then the bird's exposed, it comes down, bird's exposed, it comes down, and you can just track this in the feather. And so we looked at all the blood lead data and saw that, about 20% are exposed to levels that would warrant clinical intervention, chelation treatment, where you give them a drug to pull the lead from their blood. And the majority of condors in California have been chelated, which is crazy to me. We also found that through the feathers that they're exposed much more frequently than the blood data showed. So first of all, the blood data shows it's terrible. And then the feather data showed it's worse. So that's bad. But then we expanded the isotopic analysis and did prove that lead-based ammunition, looking at the isotopic signatures of lead in ammunition and also in fragments removed from the condor's GI tract and in their blood, that ammunition was the principal source of lead poisoning to the birds.
Okay, so a couple things I want to unpack there. Isotropic analysis. Isotopic, excuse me.
That's okay.
What is that?
So lead exists as 4 stable isotopes.
And what is an isotope?
So a form of lead. So it's like a different atomic weight.
Okay. So we're down at the molecular level here.
Yeah, so it's a different type of lead.
Okay, like some configuration of the molecule or the atom or whatever.
Yeah, protons, neutrons, things
all
like
that stuff.
Yeah.
Okay, so that's the isotope. Yeah. So isotopic analysis is looking at those.
Yeah, so you have to look at it, instead of just looking at how much lead, you're looking at how much of lead 207 or lead 208 or lead 206.
Okay, and these are designations of the different isotopes?
Correct.
Got it. Okay.
And there's 204, but we don't,
we don't care much about it.
It just makes up a minor amount. Yeah,
okay. So you're able to identify that with all your fancy equipment. And you're able to then, once you see what's in the bird, you're able to match that with lead sources that they might be encountering. And ammunition was one of them.
Correct.
Okay.
Yes.
And so you said in their GI tract, does that, so when you first started talking about this, I was imagining them being shot, but
no.
So what's happening?
So they're scavengers.
Yeah.
So if you go out and you shoot something with lead-based ammunition, and let's say you shoot a deer and you leave the gut pile, then that gut pile could be contaminated with lead fragments that you use to shoot the deer. And then you leave it there, and then scavenging species like condors, turkey vultures, golden eagles, bald eagles, red-tailed hawks, coyotes, mountain lions, whatever, could feed on that gut pile, or that coyote that was shot, or that wild pig that was controlled, and inadvertently ingest that small lead fragment, get poisoned, and die.
Okay, so now I don't hear about lead poisoning in these other species that you just mentioned.
Oh, it's a problem.
Okay, is it? Okay.
Oh my gosh.
Okay,
yeah, because I'm working on eagles right now.
Oh,
and it's
interesting.
a huge problem.
Okay, so you discovered. I'm assuming then you analyzed the ammunition, found the same isotopes, and were able to make that link. When did that happen, and what came of that discovery?
So I go back a little bit to Don Smith, because he's done this work with childhood lead poisoning. So using these isotopic analysis to identify, like, if children come into the doctor and have elevated lead levels, they've done work where they go then to the child's house and they take samples of the paint on the door of the room and samples of the dust on the dad's clothes or dirt from the front yard, and they try to determine where is the source to the child so they can do something about it. And so this technique of looking at isotopes to understand sources of lead poisoning, or inform sources, because it's not as exact, right? It's helps you just kind of understand what could be the source.
Yeah, directional in a way. Yeah, sure.
More recently, it can be adapted to wildlife. And so that's what I did with my work on lace and albatross with Don Smith on Midway, is we identified lead-based paint from the old military baits as poisoning the lace and albatross chicks. And we used lead isotopic analysis to show that.
And they were nesting near that site or something.
Yes, and the chicks were eating the paint and dying of lead poisoning, and it was horrible and horrific. But anyway, we fixed it.
Okay.
So that was good. That was a really big part, though, using the isotopes. And that's the same kind of process, or, technique, or approach is the better word. Same approach that we're using for the condors. So
you were able to make this link. Mm-hmm. And I'm aware now of a lead ammunition ban in California.
Yeah.
Is that direct your work and that ban directly linked?
Yes. Our research helped inform the ban. And Don and I put together a consensus letter for scientists talking about how bad lead is. And so we got other wildlife and human health people to sign on to this. And Don and I both testified before the California Senate for the bill.
No kidding.
And so we were hoping that, so I think my work helped inform it, which was super exciting. In fact, so lead is really bad. There's no acceptable level of exposure for humans, and for kids, there's no known level of exposure without long-term neurological impairment. So lead is really bad, and we've known lead is really bad for a very long time. And I thought to myself, if this doesn't work, if California doesn't pass this, then I'm going back out on that boat. Forget.
But, it worked.
Yeah.
And this is now at least the second example in your career of seeing science lending the credibility that kind of leads to systemic change in California. Now, that ban, I believe, was provisionally instituted in 2013.
Yeah, it sort of was, it had a phase-in period.
Yeah.
And it was completely phased in 2019.
And became permanent.
Yes.
If you haven't visited the Seymour Marine Discovery Center at UC Santa Cruz in a while, or ever, you really should come visit us. We are right on the bluffs of the beautiful Monterey Bay, with an aquarium full of local species and a bunch of hands-on science exhibits that help you understand what's happening in our ocean and along our coast. We are connecting the incredible research happening at UC Santa Cruz with real-world solutions for our coastal community. We don't want science to just sit on a shelf. We want it to shape decisions, inspire kids, and help our community feel equipped to act. So if you care about the future of our ocean and our coastal community, or you just want to experience a place that makes you feel a little more connected to it, come visit us at the Seymour Marine Discovery Center. Science Solutions, Santa Cruz. I gotta wonder, on the side of the folks who are hunting or protecting their livestock, what do they have to say about this ban?
So a lot of the hunters are for using non-lead ammunition. There's alternatives we can use. And in fact, there's some amazing organizations out there that are part of the hunting community that are trying to educate their fellow hunters about the use of non-lead, because hunters are the ultimate conservationists, right? They care about conservation, and they don't want non-target species to die because they are using a poisonous toxin shooting their meal. And they also don't want their children to be exposed to the lead in the meat that they hunt. So it's a human health issue as well. So, you know, basically phasing out the use of lead-based ammunition in California is protecting human and wildlife health.
Did you rally hunters or landowners to support this bill, or what was the sort of the interaction with them along the way?
Yeah, so I didn't, so the people that were involved with the bill, my science helped to inform it, and I testified about my science, but in terms of communicating, rallying the other groups that were involved with the effort were responsible for doing that.
Okay, so you had collaborators who were doing more of the community engagement.
Yeah. And I still do.
But even in that, I mean, that's a beautiful story of partnership between science and solution makers of all different kinds.
Yeah, I work with a non-lead outreach team all the time, today even, to talk about how our work is helping inform it. And in fact, our recent paper, which shows that it's still bad, in fact, which is sad, it's, if we want to get into that.
Let's go.
So we were really hopeful that once the ban was fully implemented, we would see a reduction in lead poisoning in condors, and we didn't. In fact, we saw that lead poisoning rates were higher.
Oof,
in fact,
what the heck is going on there?
Very, very, very disconcerting. We spent a lot of time, my collaborator Vicky Bucker and I, working on this, trying to understand why are lead poisoning rates higher now than they were 5 years ago in condors. And then with that, why are more birds dying of lead poisoning? Because if the lead poisoning rates are higher, more birds are dying of lead poisoning. And so they're still not sustainable. So there's still more birds dying in the wild than being born. And, well, we found a couple of things. So we found that, well, first of all, I should say that the reason we were able to find this is because condors are so well studied. And so we had daily data on almost every single condor in California. We know who lived, we know who died, we know who had a chick. So we have so much information.
This is a recurring theme on this show, the power of long-term monitoring in the ocean, on the coast, wherever. It's just like the power of that data seems to be transformational. So you had that.
Yeah, it was amazing. And we work really closely with the California Condor recovery people, like the recovery team and the biologists and the managers and everyone, and the non-lead outreach people. So we had non-lead outreach data that they've done as well, that they've used. And we found that condors, so we have to step back, and condors should live a long time. So actually last month, Topa Topa, who's the first captive condor brought in 1967 when he was a yearling, and the LA Zoo turned 60.
Oh my gosh.
Yeah. And they live a really long time, but they don't live that long in the wild. And the wild, they're pretty much like a bunch of teenagers out there and adolescents playing around. And so over time, their behavior is shifting. As their populations have grown, they have shifted their behavior, and they're becoming more wide-ranging, which is natural, which is what you want. I mean, a condor can fly 200 miles in a day. So
incredible.
You want them to be shifting their behavior and flying farther. And we eventually we hope that the Southern and Central California flocks will merge, because they should be spanning all across California.
That would be good there for their genetics. That'd be good for a bunch of reasons if they started to mix.
It would just be, it would be more, it would be great. But the problem is the more they're moving away from the management areas, the more they're getting into trouble. And it only takes one lead contaminated carcass to kill a condor. One small little fragment. And so it's almost like Russian roulette out there. They're out there foraging and foraging and foraging. They forage once on something that might have been shot with lead, or that was shot with lead, and they die.
And is the management or the awareness of this problem in the two regions where there are populations, is the knowledge, so to speak, higher? And so when they kind of exit these areas of people being tuned in, that it becomes more of a problem? Is there some sort of social, information breakdown?
Well, we don't have, we looked for evidence for that to show, but we do think that that's probably what's happening.
Okay.
That people have ranches around Pinnacles National Park and they're always talking about the condors or hearing the condors or seeing the condors. They might be more aware of the law to use non-lead ammunition. That's one thing. But the other thing that we found, besides the fact that if they're going farther, and again, we have these daily data, they're more likely to be lead poisoned, is that pig hunting is a huge problem now, and pig deprecation or control. So wild pigs in California populations are growing, and they cause so much damage, and they like wreak havoc on people's farms and vineyards and all kinds of things. And it's pretty much private land, and people are shooting those pigs. And we think that that some of those pigs are being shot with lead ammunition, and they're killing the condors. Because one of the risk factors that we found that was linked to this higher, basically poisoning condors today than 5 years ago, is there are more pigs being killed. And that is positively related to it.
So why? Okay. I mean, we've identified this maybe sort of social awareness gap, so to speak. Is there any other reasons why you would believe that lead poisoning would be worse today?
Because they're worse. The pigs are worse.
The pigs are worse.
Yeah.
So it's just, there's literally just more bullets in pig carcasses than there were 6 years ago.
That's what we think.
Okay.
And that's what the models show. The models are showing that the pig, like the more pig hunting, the more likely the bird's lead poison.
And is this mostly depredation activity, or is this like recreational hunting on the pigs?
So it's both, but we think that the depredation is the main driver, because that's hard. So pigs are now listed as an invasive species, and they're causing lots and lots of damage. So there's not that much in terms of the reporting and how many pigs are controlled on your land isn't that good, but it's maybe getting better. So
just because in the historically there was no reason to sort of track or. And
I think because they're so problematic and they're such a pest species now that, like, if they're on your land causing problems, sure, you can control them.
Yeah, I mean, it's almost like rats up in the Santa Cruz Mountains. Like, you know, people are doing what they're doing with rats all the time. And it's so pigs are sort of starting to move into that category of like, we just got to take care of them.
And they do cause a lot of damage.
Yeah.
So I have a story about that.
Please.
Okay, so we were trying to figure out what's the problem. And one of the things, too, is condors will feed on ground squirrels. So people shoot ground squirrels. And sometimes it's hard to find non-lead alternatives for ground squirrel type, the bullets you use for ground squirrels. So we thought, well, maybe it's, ground squirrels, because we do think that that is a source that's out there. But we were trying to think, well, how come it's worse now? We kept getting to the worst thing, right? And so we were talking to the non-lead outreach people about this, and we kept like saying, well, what's worse? Why is, like, are there more ground squirrels out there today than 5 years ago? We're looking at rain data. We're looking at anything we could figure out. And he's like, no, not really. And so we said, well, could more people be out there hunting ground squirrels today than 5 years ago? He's like, no. He's like, but there's sure a lot of pigs out there now. And we're like, wait, what? Wait, what?
Pigs, squirrels, like what?
Yeah. So we got all the pig hunt data and deer hunt data, and we determined that, which is cool, after the ban, that basically the more deer hunting, the less likely a condor will be lead poisoned. So it's protective, because we think they're using non-lead. So by and large with deer hunting, like, more of it is better for condors. More deer hunting, less lead poison condors.
Wait. When you say more deer hunting, is that like in place of hunting something else, or
just like number of tag returns?
Okay.
So after the ban, we're looking at like how many tags, deer hunt tags there were sold, and how many like tag return data there was.
And a tag return is when the hunter
like buys the tag, and I'm not a hunter,
yeah.
That it's basically records if they hunted that deer, purchased that deer.
I see. Okay. And so I'm just trying to make the link of more deer hunting that's using the non-lead ammunition.
Well, we think that's got to be the case.
Yeah.
Why?
And does that just mean like the condors then they have more healthy food essentially?
Yes.
Okay. All right.
So what we think, I guess, and I should say we feel the most important point of that is that the ban is working.
Okay. Got it.
I see. So the ban is working.
I see.
And that if we didn't have the ban, it would be so much worse for condors. It's just that we have these other factors that are causing problems. And it only takes one event to kill a condor.
And so, okay, so now we're getting to this little ammunition, the 22s for the ground squirrels or whatever,
and also air rifles too. And air rifles are not covered under the ban. And we had
interesting.
Yeah, and we had a condor die in the Northern California, the new tribe, the newly established flock in Northern California. We had a condor die last year from had an air rifle fragment in its digestive tract, lead-based air rifle fragment.
Okay, an air rifle differs from a standard rifle how?
It's not a firearm.
Okay.
Classified. Again, not
okay,
a
so
hunter.
it doesn't fit under the bill because it's a different technology, essentially.
Yeah, but my understanding is they've gotten much more powerful, and now you can use air rifles to hunt deer and pigs, where before maybe not so much. And so now we're seeing this sort of issue with air rifle pellets as well, which are not covered under the ban.
So three potential problems and therefore solutions are coming to mind for me right now.
Yeah.
Okay. One, air rifles not being included in the ban.
Yeah.
Maybe we get them included. Number two, the smaller ammunition, the 22s or whatever,
have to become available in non-lead.
They have to become available.
Yeah, easily available. Right now, it's very, very hard to get it.
And then the third is just the sort of the social awareness and the sort of social education.
Yeah, that's
so
important.
Which of those three do you, if you had to pick one, you're like, this is going to be.
It's not just one.
Okay,
it's like
all right,
children.
all right,
no,
all
no,
right,
no.
all right.
I think I would love to see air rifles included.
Okay, yeah.
Because I just think that's a source, and we're seeing that as a problem, and I think that's kind of a bit of a loophole.
Mm-hmm.
And I don't know if there is more air rifle. Like I haven't looked at information. I don't know where we'd find that. Are more air rifles being used now than they were before? But I know that there are websites that sort of show that this is a way to kind of avoid the lead ban in California if you're going to hunt.
So there's like this subculture of being like, get an air rifle because it won't limit your ammunition choice. Interesting.
Well, I just think that that's out there.
Yeah.
I mean, I know it's out there.
Yeah.
But I also think education is ultimately the key.
Yeah. Are you involved in any of those sort of three options that we just laid out, like actively today?
Well, I am still working. I mean, we just published that work looking at showing that pig hunting in control is a big problem, and that we're hoping that with that, the Fish and Wildlife Condor biologists are working with Fish and Wildlife, California Fish and Wildlife, to help educate, and the non-lead outreach people are trying to help educate people about this, because I also think it's an education issue.
Yeah.
And I don't think people are trying to break the law. I think they don't know that what they do on their private land actually that's not that falls under the law. And
like you said, it seems like once that information is available, people are willing to participate because they're like, I don't want condors to die, and there's no reason for me to want to advance that. I mean, I could see there being objection around, maybe if the cost of non-lead ammunition was higher than lead ammunition, and that could present some economic problems. So I could see that, but in the heart, right? It seems like you haven't run into too many objections on this.
Well, we have.
Okay.
Mostly, I think, so there has been cost issues, but there's been work that's shown that for the same quality of bullet, the cost is about the same.
Okay.
But like air rifle pellets are super cheap. So there's that. And then there are people that do not like being told what they can shoot from their gun.
Right.
And there's a huge sort of like issue surrounding that.
Yeah.
And we've had pushback in that area.
Yeah.
Whereas when I told you about my work on lead poisoning lace on albatross, when we determined that it was the paint that was the source, we didn't have anyone question our science and tell us, oh, it's not really the paint, or it can't really poison them, or, we had no problem like that. The barrier we had for action was more, it's only affecting chicks. It doesn't affect the population level. How big of this is a problem with all our other problems on refuges. But for the California work, for California Condor work with looking at the lead-based ammunition, we've had a lot more pushback. Since the ban, it was getting worse. There were people that were saying, we told you it wasn't the ban. Exactly. But we do still firmly believe we still find birds with, lead fragments and lead bullets inside of them that have died of lead poisoning. And the work has shown that the ban actually has helped save birds.
So what do you see happening next, either in your science or on sort of the solutions? What, if you could put on your clairvoyant hat, right, like what do you see coming down the pike?
Well, I do know that there are efforts in other states in the country. So California is the only state in the nation that restricts the use of lead-based ammunition.
Oh, wow.
And so I do know that there are efforts now that are coming up in other states in the country to try to restrict, kind of following California's lead.
Okay.
And we're hopeful with the new work showing that the ban was actually effective, that will be supportive for that, because I really feel, I guess for my head, I'm working on lead poisoning in golden eagles and bald eagles as well, because this is not just a condor issue. And it's, again, not just a wildlife issue, it's also a human health issue. You know, people in other states, they're hunting with lead-based ammunition and then giving those that carcass to food banks and then feeding people potentially contaminated meat. And I'll just back up again and reiterate, there's no acceptable level of lead exposure for a young child. Oh, I just feel like we talked about me on the ship and looking at all the pollution and all of those things I worked on, like these legacy pollutants for my PhD as well, like polychlorinated biphenyls and organic pesticides and this sort of everlasting stuff that we've put into the environment that is just going to be really hard to take care of and really hard to clean up. But I feel for lead-based ammunition, like it's an easy switch.
Yeah, we can do this one.
We can do it. We can save so many birds and so many scavenging species. And we can help protect humans. It's just an easy fix. It just, people don't want to do it.
I think this is such a beautiful, what you just said is so beautiful, because we started this conversation with little 7-year-old Myra wanting to save all the animals, and here you are doing it.
Oh, it's trying. But I have a huge team with me. I have a huge team. Science is not in isolation.
Yeah, shout out Myra's team.
Oh my gosh. I cannot do any of this alone. They're amazing. And yeah.
Before we wrap up, actually, I do want to read. After seeing the condors in pinnacles, I went on, started researching on the national park website.
Yeah.
And there are some, I don't know who writes these things at the national park, but there are some incredible profiles of these animals. Are you aware of these?
Yes.
I just gotta read my favorite one, and because they're kind of written almost like scandalous affairs or something like that.
Yeah, they all have their own personalities.
Well, here's one that I loved. This is a scandalous affair. This is a quote from the National Park Service website. Blood tests revealed that although 589, that's a designation for one of the animals, 589 raised 996 as his own, he was not the biological father. 569, the mother, apparently had some alone time with Condor 606 earlier in the year, and this younger male turned out to be the real father of 996. Scandalous.
Yeah.
Anybody listening, you should go on this hike to the High Peak.
High Peaks Trail.
High Peaks Trail.
Pinnacles National Park.
Yeah, is there a best time of year?
Not when it's very hot, because it gets really hot there.
Yeah, well, yeah.
So probably spring is good.
Okay, all right. And do the condors come up this far up to Santa Cruz?
Yes, they sometimes do.
Okay,
But,
all right.
Rarely.
Around here we have turkey vultures, so maybe sometimes you might mistake one for...
But you could drive down the coast to Big Sur and you might see them.
Yeah.
Feeding on a marine mammal.
Yeah. Is there anything about condors or environmental toxicology or anything that we haven't touched on yet that you want to make sure you get out today?
I guess, well, for the condors, which we did talk about, but I do always like to reiterate it, is that it's not just condors.
Yeah, okay.
Lead-based ammunition is poisoning any scavenging species. It's not just California. It's not just the United States. It's a global issue. So it's a problem in Europe. It's a problem in Japan. It's a problem in Canada. It's wherever you're basically shooting something with a lead bullet, you could be potentially poisoning a scavenger or yourself.
Is there anything that somebody listening might be able to do, say if they're a hunter, obviously, like please purchase non-lead ammunition, but if not, is there anything that someone could do to support the effort in any way?
Well, there are organizations like, Ventana Wildlife Society is great, and they do have a non-lead ammunition giveaway program, which has been amazing. And in fact, we showed that the more lead ammunition boxes given away, the less likely a condor is going to be lead poisoned. So it actually helps as well.
So can you donate and help purchase ammunition then?
You can.
Okay.
And also there's a great website, huntingwithnonlead.org, from the Institute for Wildlife Studies. runs that. And so that has a lot of really good information because, as I've said multiple times, like, I'm not a hunter. I don't know that much about guns and bullets, but they know a lot. I mean, the team I'm talking about, like, they know. I don't know. So I would definitely reach out to them and go to them if you have any questions. If you're trying to find non-lead alternatives and you can't, reach out to them.
Okay, fabulous. Well, before I let you go for the day, I have a quick lightning round of questions for you. You know, we can blast through these real quick. All right. If you weren't doing this job, what would your alternate reality career be?
Yeah, I'd probably be out on that ship.
All right. Question 2, what's the best piece of advice you've ever received from a mentor?
So I once had a mentor. So David Brower was a mentor of mine for a fellowship that I had in graduate school. And I don't know if it was specifically a piece of advice, but it was just that he made me feel that anything was possible and that I could help fix the world. And I think it's more just that, just like that, just having, like, making sure that you let other people know that they can definitely make a difference and that it matters.
And here you are doing it, Myra. So that's amazing. What's your favorite outdoor spot for a quick hit of nature?
Well, for really quick, it's probably to just like take the dog for a walk down to the ocean. And that always brings me peace to look out on the ocean.
Me too. What's a book or a movie or a TV show that you would recommend to fans of this show?
Okay. So I also work with plastic pollution, which is not surprising. And I think that for a documentary that is a bit depressing, but really good, is The Story of Plastic. And the UCSC, if you're affiliated, does own it. You can also get it on Amazon, but it is kind of heavy. So then if you want to go just for a fun afternoon with your friends and family, we saw Sheep Detectives last weekend with my mom and kids, and we loved it.
All right. I've got a 6-year-old, so maybe I'll bring him. Great. And what gives you the most environmental hope right now?
So 2 things is the people I work with and knowing that there's so many people out there that care and want to do good things. And it's also my undergraduate interns that are just very inspired and passionate and fired up. And I just see them and I think of myself back as an undergraduate and they want to make a difference. I mean, I think they would be out there jumping on the ship if they could, honestly. So yeah, it gives me hope.
That's wonderful to hear. Well, Myra, thank you. Thank you so much for everything that you do and for coming in today to talk with me about it.
Thank you, Jonathan. It was great to be here. Yeah, thanks.
All right, that does it for the pod. Thank you, Myra, for coming on today. You're an inspiration and a total badass. Thank you to everybody on Myra's team and in her lab. Thank you to everybody working to protect the California Condors, including but not limited to the Ventana Wilderness Society. And of course, thank you to Edith Belmont for editing, Cassidy Beach for production, Valerie Situ for distribution and socials. And thank you for listening. We'll see you next time.